Welcome to National Grid Construction. I'm delighted to have you on the team, and I hope you found this induction process informative to the point that we can all work safer. It's a team game. I like everybody to take responsibility for their own safety, but also to take responsibility for the team and watch out for others.
There are several thousand kilometres of high-pressure pipelines beneath the countryside. The provision of gas to industry and domestic customers is essential to the UK economy. There is continuous work on strengthening and updating the infrastructure, which consists of above-ground installations and the thousands of kilometres buried in the ground. National Grid is committed to the protection and enhancement of the environment, always seeking new ways to minimise the environmental impacts of our past, present and future activities. Physical features such as rivers, gorges and special habitats like wetlands or moors must be protected, whilst air quality, noise levels and visual impact must all be considered to minimise the effect of construction activities. To control the volume of waste produced on large-scale projects, pipeline teams endeavour to reuse and recycle materials. Where the production of waste is unavoidable, correct waste streams must be used to dispose of the materials. Similar to all other industries, the cross-country pipeline sector has its own terminology, so we will be explaining the various terms used as we follow the pipeline route. The workplace is known as the spread, and the route that the pipeline will take crosses public roads, rivers, streams, and in some cases, railways and canals. The work carried out in constructing a pipeline is always done with minimal impact on the environment and the people who live nearby. Great emphasis is placed on communicating with the authorities and the public. The environment is taken into consideration when the pipeline route is being planned, and detailed actions are followed to protect plants, animals and birds. Historical sites are also protected. During the planning of any pipeline, all known designated sites are identified and avoided where at all possible. Where avoidance is not possible, then special mitigation measures are implemented to minimise the disturbance of these sites. To support this process, the cross-country pipeline industry employs environment and ecological specialists. The construction of the pipeline requires a team of people with a wide range of occupations and skills, working together to ensure the pipeline is constructed safely and with minimal impact to the environment. National Grid requires compliance with the Safe Control of Operations procedures. This would also apply to risk assessments, which recognise and register the particular challenges on a project, and as a result, produces change in method statements. It is important that everyone is aware of their responsibilities as an individual, to know where to go for help and who to report hazards to. This may be easier for those experienced in pipeline operations, but each project involves new starters or new subcontractors who will need to integrate themselves in the project team. Each pipeline project requires people with a range of skills and competencies. Competence is defined as an individual with the relevant information, knowledge, training and experience. Each pipeline project is unique, and the planning process is thorough. A great deal of information and process design is carried out before the first sod is removed. A walk-through survey and boreholes are carried out. The route is surveyed, and pegs normally indicate the pipeline route. The extent of the spread is also marked out. Before construction works commence, the route of the pipeline is subject to detailed ecological and archaeological surveys. These surveys highlight the locations of protected species along with valuable habitats and archaeological sites. Based on this information, the route is once again revised to avoid unnecessary environmental impact. Dependent on the route, a plan needs to be made regarding the safety and protection at road crossings. Plans would also need to be developed to allow for safe movement of plant and vehicles to various points along the spread. In some cases, project traffic will be banned from some of the local roads. The route soil conditions, environmental and archaeological surveys produce data, which is to be used to compile the environmental management plan. Archaeological finds are noted and excavations are made for relics and information collected where necessary. On occasions, either environmental or archaeological issues have caused pipeline routes to be adjusted. Trial holes are used to identify depth and location of any third-party services. Protected species are these animals and plants which are protected by law. Commonly encountered species include bats, dormice, badgers, newts and reptiles. Some species of fish, insects and birds are also protected. Initial stage hazards are taken into account at the planning and routing stage. Those hazards might include the proximity of the pipeline to areas of population and the geographical conditions to be found along the route. Other hazards relate to the work of employees entering other people's land whilst carrying out tasks such as environmental and archaeological surveys. Clear communication with all parties is vital. The protection of the public, environment and animals is important to the project, and therefore fencing is installed along both sides of the pipeline route. Allowance has to be made where there are public rights of way crossing the route. Road crossings need to be properly protected. In certain conditions, pre-construction drainage needs to be considered in order to provide the best way of protecting the pipeline operation from water-filled trenches. Survey results will also indicate the position of any underground services encroaching or crossing the spread. These are then dealt with as part of the operational plan. Power lines are included and strict regulations are followed regarding the movement of plant and pipeline operations in this area. The area is normally marked with bunting, which indicates height restrictions. Hedgebank material and translocated species are retained on site, protected with fencing and clearly identified. This material will be returned to its original location during reinstatement. As the spread is constructed, all breakthrough activities, such as hedgerow removal and vegetation clearance, are supervised and monitored by field ecologists. They will ensure that no changes have occurred since the reconstruction surveys. If protected species or nesting birds are found, then works are suspended and mitigation measures are devised. Sometimes works are delayed or even stopped completely until the protected species are moved. Topsoil is an extremely valuable natural resource which must be stored correctly and left undisturbed until the spread is reinstated. Topsoil is generally stored at the edge of the spread in smooth-sided piles. The smooth sides help avoid erosion from the weather. Weed growth is controlled as appropriate. All topsoil stripping and excavation operations are carried out under the watchful eyes of trained field archaeologists. These are known as watching briefs and frequently expose finds and artifacts that were not previously known. These are then recorded and excavated in accordance with procedures agreed with the archaeological governing body. Some finds may also lead to the route being diverted once again. Invasive plants are increasingly common throughout Britain. Special measures must be adopted to deal with these plants. Invasive plants often found along pipeline routes are giant hogweed, Himalayan balsam, Japanese knotweed, common ragwort and rhododendron. Rock blasting is sometimes required in order to enable excavation of the trench for the pipeline. There are a number of techniques used on pipeline construction that allows rivers, roads, railways and canals to be crossed without disturbing the infrastructure concerned. This could involve the use of auger boring, where a drill is used to tunnel through and the pipe is pushed along with it. Directional drilling and micro-tunnelling are different techniques that have the same objective. As you can see, the processes described need a lot of machinery and plant. Fuel use, handling and storage during construction is another potentially environmentally damaging aspect. Refuelling is carried out under strict guidelines by authorised persons. Accidental spills should be cleaned up immediately. Hazards that have considerable impact on personnel include uncontrolled contact with underground and above-ground services, deep excavations and trenchless crossings, noise from plant and machinery, along with the movement of plant and equipment. The pipes are transported to prepared pipe storage areas. These are fenced-off areas of land that act as an open-air warehouse for pipes. The ground is cleared, fenced off, and its location is in agreement with local authorities and police, with special emphasis on access and egress. Pipes are rested upon sand beams to prevent movement. There is a technique used to stack the pipes safely. The pipes are transported from the pipe storage area to the spread and laid out at slight angles to the pipeline route. This is known as stringing. Each pipe length is precisely positioned along the pipeline spread. This is dependent upon ground conditions and obstacles to be encountered along the route. There are activities that are generally carried out in a location off the spread. The location is called the construction yard, and this is where fabrication activities are normally carried out. The completed items are then transported to the spread. Pipe bending is normally carried out on the spread where specialised hydraulic bending machines are used. The movement of lifting equipment and other plant around the storage site, including their use, is regarded as hazardous. Transportation into the storage site and onto the spread is controlled by a traffic management plan. The loading and offloading of pipework on the spread, where the ground is uneven or unstable or close to open excavations, is also regarded as a hazard. The importance of an accurate stringing operation can be seen when the front-end welding operation commences. The welds are prepared and are carried out either by welders or by automatic welding machines or both. Again, the use of welding sets and protective tents with a team of welders and mates provide a scene of high activity. All welds are tested either using ultrasonic testing or radiography. This is to ensure the welds meet the required standards. The use of radiography requires strict adherence to rules that include the setting up of a prohibited zone around the test area, with both visual and audible warnings of test commencement. Ultrasonic testing involves the use of ultrasound that checks the joint's validity. Both radiography and ultrasonic testing are specialist operations, and the hazards are controlled within the prohibitive zone. The joints are blasted, cleaned, and a coating is applied for protection. The welded pipe string, which will vary in length, is now ready for the lower and lay operation. Hazards that have a high risk involve the operation and movement of plant. Working in excavations, especially in tie-in operations, is regarded as high risk, with the potential of trench collapse. High-quality engineering design is essential. Welding operations involve hazards that are a risk to health of operators and those working close by. The hazards include arc welding, fumes and heat. Another area creating a hazard to health is the coating operation, where dust and fumes are generated. Radiography has its own set of hazards and is strictly controlled. All non-specialist operatives are excluded from the testing area. The excavation is carried out using trench machines or excavators. Particular care is taken to avoid damage to underground surfaces. This is regarded as a major hazard. Excavated soil is banked on the opposite side of the spread to the topsoil, away from the excavated edge. Excavated materials should not be moved from one farm to another without the consent of landowners. This ensures the integrity of organic farms and helps protect the soil structure. The pipe string is placed in the excavation by using a series of side booms, under the instruction of a lower and lay foreman. Lifting operations of this kind are recognised as hazardous. The level of risk is reduced by ensuring operators are competent, the person in charge of the lifting operation is competent, and the equipment is fit for purpose. During dry weather, pipeline construction activities can generate airborne dust. This can cause environmental problems by coating the leaves of plants. It is also a health risk to the workforce. To combat this, dusty areas are sprayed with water and the site speed limit may be reduced. During wet conditions, it is important to control the rainwater running off the spread. This runoff can collect large amounts of silt and enter natural watercourses, causing pollution. To control runoff, grips supported by berms and sumps are installed to direct water off the spread. Silt fences may also be installed. It is everybody's responsibility to ensure that these mitigation measures are maintained throughout the bad weather. Pumping operations are often necessary to keep ground conditions stable during excavation. The pumped water must be dealt with correctly to avoid saturating the adjacent ground or depositing silt in unwanted places. Sediment traps and filtration lagoons must be large enough to deal with the volume of water being pumped and must also be regularly maintained to ensure silt is controlled. The laid pipe sections are connected together in the excavation by the tie-in welding team. After completion of the weld, radiography and coating of the pipeline, the excavation is backfilled using selected backfill material, which is then compacted. The remaining subsoil is placed in position and then the topsoil is replaced. Final ground preparation is agreed with the landowner. In some areas, it is not possible to return all the excavated material to its original location. This leads to surplus material which must be disposed of in accordance with strict environmental procedures. All removed sections of hedgerows are replanted with the same species as were originally removed. These are sourced from local stock where possible. Where side booms and other heavy lifting equipment are in operation, this is classed as a high-risk activity. Other hazards to be encountered are where excavators and trench compactors are being used to put back the excavated material. The pipeline must be tested to ensure there is no leakage and that it can withstand normal operating pressures. The test is known as a hydrostatic test, which lasts for 24 hours. Testing of the pipeline may be staged across a project with different sections being tested at different times. All these operations are subject to a permit.